In the kettle, when we switch it on, we're allowing electrical energy to come into the kettle and it's converted into thermal energy inside the kettle. In the filament lamp, when we switch the filament lamp on, electrical energy comes in and it creates light, but also quite a lot of heat here. A lot of the energy that's given off here, thermal energy is given off in the infrared part of the spectrum, so we get a lot of heat given off. In this LED torch, when we switch it on, we are converting chemical energy in the battery into electrical energy, and then the electrical energy is converted into light energy. So we have chemical to electrical to light. In the solar cell here, we're converting a light energy into electrical energy, and then we can use that electrical energy to drive this motor and create kinetic energy. So when I remove the card, the sun shining down on the solar cell is converted into electrical energy coming through the wires to kinetic energy. So we have light to electrical to kinetic. The leaf represents plants, and what's happening with the plants is we have light energy coming in and being converted into chemical energy. So the tree or the leaves are converting the light energy into chemical energy, and that's stored as food inside the trees or in terms of cells, growing cells. We see the tree leaf as green because it absorbs all parts of the spectrum apart from the green. So it doesn't really use the green part of the spectrum, and that's reflected back, and that's what we see. So actually most of the light that is being absorbed by the leaf is in other parts of the spectrum. The water heater is converting electrical energy, which is coming in through this cable here, into thermal energy, heating the water. And if I switch it on, we get some water flowing. So electrical energy is being converted into thermal energy, producing hot water. Newton's cradle, we are converting gravitational potential energy when the ball is up here into kinetic energy as it falls down and then strikes the other balls, and then at the other end the kinetic energy is converted back into GPE again. So we have GPE to kinetic to GPE to kinetic to GPE in a continual process. It won't keep going forever. There is a little bit of energy lost as heat and sound. You can hear the balls clicking, so that's some energy loss, and there's also a little bit of heating inside the balls. In the hand generator, we are converting chemical energy from our body into kinetic energy as I wind the handle, and that's converted into electrical energy in the wires. So we have chemical energy in the body to kinetic energy in the handle to electrical energy, and then that goes to the lamp here, and that creates a bit of light and probably some heat as well. In the batteries here, we have chemical energy stored, and when I connect it to a circuit, it creates electrical energy. And then we can use that electrical energy to power a number of devices, but in this case, we're powering a fan, so we have kinetic energy. So we have chemical energy in the batteries, to electrical energy in the wires, to kinetic energy in the motor. When you lift a mass, you are converting chemical energy in your body into gravitational potential energy as you raise the load up against gravity. So we're working against its weight. We have to provide a force to lift it up, and so we are converting chemical energy to gravitational potential energy. In this water turbine here, we're going to use the kinetic energy of the water to generate kinetic energy inside the turbine. So when I switch the water on, the turbine is spinning inside here. And what I could use is I could use the spinning of that turbine to drive electrical generators, for example, in a hydroelectric dam. So we have kinetic energy of water to kinetic energy of turbines. There's not a direct energy transfer as such, it's kinetic energy to kinetic energy. In the fan, we are going to convert electrical energy coming in through the wires here to kinetic energy of first of all, the blades of the fan, and then to kinetic energy of the air as it's blown outwards. So we have electrical energy to kinetic energy. Now we can use that kinetic energy in our next device, which is this turbine. So in the turbine, the wind generator, we have the kinetic energy of the wind converted directly into electrical energy. And this is exactly the same as onshore, offshore wind turbines. We're converting the kinetic energy of the wind into electrical energy. So in the Peltier motor, we're using a difference in temperature between cold and hot water to convert into electrical energy and then drive a little motor. So the difference in temperature between the hot side here and the cold side creates a temperature imbalance, and that can drive the Peltier motor. So we have thermal energy into electrical energy into kinetic energy in the motor. In the candle, we're converting chemical energy stored in the wax and the wick of the candle into light energy, and obviously thermal energy as well. So we have chemical to light and thermal. This is just a standard battery, and in a battery we're converting chemical energy stored inside the battery into electrical energy. So we have chemical energy into electrical energy. This is called a solar water heater, and the solar water heater is converting light from the sun is absorbed by the metal plate, and inside this tube is some water which heats up. So we are using light energy to create thermal energy to heat some water, which, if you had this situated on the top of your roof, would be able to provide hot water for showers and baths and washing up. So we have light energy into thermal energy.